A transformer has a primary coil with 60 turns and a secondary coil with 2,300 turns. If the primary voltage to the transformer is 110 volts, what is the secondary voltage? Is it 2.4 times 10 to the minus 4, 2.4 times 10 to the 2, 1.3 times 10 to the 3, or 4.2 times 10 to the 3? So remember, to answer this one, once again, all we need to do is use our equation for the voltages in a transformer. V1 over V2 equals N1 over N2, right? So if our turns are 60 and 2,300, then our voltages will be in that same ratio, right? So if the secondary coil has more turns, it'll have more voltage. And the ratio tells us that our answer is going to be 4.2 times 10 to the 3 volts. That is 4,200 volts. Question 11. What is the function of the slip rings on an AC motor, not an AC generator? Is it to change the direction of the supply current flowing into the coil, to provide electrical contact between the coil and the external circuit, to provide a constant magnitude torque on the coil, or to change the direction of the torque on the coil every half revolution? Now, if we have a motor, we don't want to change the direction of the torque on the coil, right? That would result in the motor stopping. So it's not going to be D. We also know that we're not going to change the direction of the supply current because that's already changing, so it won't be A, right? If we provided a constant magnitude torque on the coil, then we would need to have a motor that doesn't use slip rings. We would need perhaps a squirrel cage motor. In an AC motor that uses slip rings, we don't get constant torque. The only answer remaining is B, to provide electrical contacts between the coil and the external circuit. That's all the slip rings do. Question 12. Which option best describes the difference between the structure of a motor and the structure of a generator? Are the sources of power, the commutator, the brushes, or the magnetic field different? Well, we know that we can construct both of these with a permanent magnetic field, just pointing in one direction, so the magnetic field can be the same. The brushes can be the same, and so can the commutator, because these just provide contact between the external circuit and the coil, right? Whether that coil is receiving electricity or producing electricity. But therein lies the actual difference. One of the coils produces electricity and the other one receives electricity from an external source. So in both cases, the sources of power are different. In a motor, the source of power is the electricity that's being used to turn the coil. But in a generator, the coil is sort of turned by hand, and then the electricity is pushed out by that.